Hello everyone. Today let's solve the problem number 1863, sum of all subset XOR totals, right? So what the question states here, we need to find the sum of XOR totals of all the subsets of the given array. The XOR total of a subset is the bitwise XOR of all its elements, right? 0 if empty. Just keep this in mind. 0 if empty, right? So we consider all the subsets including empty and the full ones, and their sum and their XOR totals. And there we consider all subsets including empty and the full ones and their XOR totals, right? So here let me come to the first example. Nums we have here 1 3. The output that we need to get here is 6, because the four subsets of 1 and 3 are, so here they have clearly mentioned the empty subset has an XOR total of 0, right? So every time the empty subset has an XOR total of 0 itself, right? So this way now. So let's consider the four subset. This is also one of the empty subset is also one of the subset, right? So now we have three other subsets left, nothing but 1, 1 3, 1 individual 3, and this one 1 3. These are the subsets we are left with. One has an XOR total of 1 itself, right? So 3 has an XOR total of 3. This we have to convert this one to the binary, and we have to go with a truth table. Basically, let me tell you, XOR truth table I'll just give you here, so you can just check the same thing, man. If you're not understanding, so here 1 and 3 will go, right? So here for 3, let me give the truth table, you can just check the same actually, right? So when suppose if we are having two values a and b, so this one will be 0 0 1 1, this one has to be 0 1 0 1, right? So 0 0, when only we have both ones, then only it is true or 1, else it is 0 itself, else it is 0 itself, right? For all the other things it is 0. Only when both ones we have, then only XOR we have 1 basically, right? So you can convert this one to the binary, convert the 1 to binary, and you can perform XOR basically, right? So 1 3, this one. So this is fine. 1 has an XOR total of 1, and 3 has an XOR total of 3. 1 comma 3 has an XOR total of 1 XOR 3, that will lead to 2. So this I showed this one. For the 1 you can just go with 1, for the 3 you can just go with the 3 directly, individual numbers, right? So this will be 0 plus 1 plus 3 plus 2, which will give us the output 6, right? So same goes with the example 2 and example 3 as well, right? So same goes with example 2 and 3. So I can just check it out in the same way, right? So I hope the question is completely clear, man. Let's discuss the approach in detail, and then let's go with the this one, complexities, and then let's write the code. First, as I've said, we will be going with a backtracking approach, right? So again, I just want to mention that we will be going with a backtracking approach, right? So just keep this in mind. So the first step, let me consider the same first example. Here, right? So for the approach, so first what we'll be doing, we will be using the backtracking to explore all the subsets, right? So we'll start from the index 0 with current XOR equals 0. That's what we'll do. At each step we'll be choosing the include or exclude, right? Including or excluding the current element. When we reach the end, we will add the current XOR to the sum. This is the thing that we'll be doing. In simple terms, these are the three steps we'll be performing. Let's see the same thing, right? So by considering the example, so here we have 1 comma 3 within the array. We have been given 1 comma 3, and we are going with the backtracking, right? So let me make this one array look good. So this is fine, 1 comma 3. So first what we will do accordingly with the approach, so we will start, first step we will start with the current XOR. I'll just give here CX, nothing but current XOR, this is 0, right? So we have to include 1, right? So we have to include 1, also include 3, right? So this will be the second step, include 1 include 3. So this will be XOR of 1 3, XOR of 1 3 equals 2. So this one we will be adding this one to the sum, right? So this is fine. So now include 1 exclude 3, include 1 and exclude 3. So we will be adding 1 to the sum. right? So we have to include one. That is the reason I showed you the truth table as well. We will be including one and excluding three. So we will add that one to the sum because we have individual sum and we have to consider all the subsets, right? So here in this case we have four subsets. Empty subset, we have to go with zero always. So 1 3 and 1 3 are the three more subsets, totally four subsets. So we will be including one and excluding three. Next we have to exclude one and include three. So here in this case we have got three, so this we will be adding this one to the sum as well, right? So this one to the sum as well. Now we are having 0 2 1 3. The final step is we have to exclude 1 and 3 both. When we exclude 1 and 3 both, so this one exclude 1 as well as 3. When we exclude both 1 and 3, we are left with 0. We are left with 0. So we will be adding this 0 to the sum. We will be adding this 0 to the sum. Now let's consider all the values from here, right? So 2 1 3 0. 2, we have to sum up all this thing, right? 2 plus 1 plus 3 plus 0. So here the output that we got here is 2 plus 1 3, 3 plus 3 is nothing but 6, right? So this 6 we will return this one as output. Sum we got here is 0 plus basically 0 plus 3 plus 1 plus 2 and anything, so it doesn't matter. This one, what do we call, order doesn't matter, man. Here this will be 2 plus 1 plus 3 plus 0, right? So we went with 2 plus 1 plus 0. You understood, right? So we went with the XOR 1 XOR 3 for 1 3 subset, 1 comma 3 subset. For only one, we have to go with the 1 and exclude 3. For only 3 subset we have to go with the 3 and exclude 1. And when we consider accordingly with this one 0 and 0 also we have to go with, right? So in the truth table 0 and 0 will lead to 0, right? So we lead to 0. We have to exclude 1 and 3 both. That is also one of the steps, right? So when we exclude both 1 and 3, we will get 0 itself, right? So that also we need to consider. That will lead to 2 plus 1 plus 3 plus 0, nothing but 6 here. We got the output 6. We got the output 6 here. This is fine. Yeah. So this is it for the approach. This is it for the approach. Just remember this one. This is it for the approach. Uh, Now we are done with the approach part. As we are done with the approach part, let's move on with the this one. What do we call complexities part, man? Right? So what will be the time complexity here? As we are going with a pure backtracking here, the time complexity would lead to 2 to the power of n. Sorry, this one, yeah, 2 to the power of n. So why it is 2 to the power of n? Each element can be either included or excluded, right? So it depends upon the number, this one, the number of elements present in the array, right? So here each element can be either included or the excluded because we have to perform the XOR operation. So overall time complexity would lead to big of 2 to the power of n. So what would be the space complexity here? The space complexity would be big of n as well. So why it is big of n? Because we will be going with the recursion. Backtracking is nothing but the recursion itself, right? So we will be making a recursive call, and recursive call stack depth in the backtracking can go up to big of n. So overall space complexity would lead to big of n. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of 2 to the power of n and big of n respectively, right? So this is it for the complexities part. Let me delete this one. This is it for the complexities part, right? So we are done with the approach and complexities. As we are completely familiar with the approach and the complexities, we are good to write the code. Let's start writing the code. So the first step here would be we have to call the backtracking function, this one. So let's do one thing. Before calling the backtracking function or writing the backtracking function within the subset, this one main function itself, let's make use of the helper method. Let's go with the helper method, or let's go with the helper function. So let's go with the backtracking function just to explore all the subsets here, right? So I'll just go with private int backtrack. It consists of the parameters here. What are the parameters we need? One is numbers we need. This is fine. Also we need the index and the current XOR, right? So for the index I'll just go with idx, and also for the current XOR I'll just go with current XOR. This is fine. Yeah. So within this method, what shall we do? Let's go with the base case. Means if we have reached the end, then we have to return the XOR of this subset. Means if index equals length of the nums, means here nums dot length. So then what we need to do, nums dot length, then we have to return the current XOR. Means I'll just go with return current XOR. This is fine. uh, this subsets XOR contributes to the sum. Basically, we know this one, man, from the approach. So let's go with the first choice. What we saw in the approach, we went with the three choices, right? Either we can include the current element in the subset, or we can exclude the current element from the subset, or the final one is we just have to this one, these two choices itself, right? Include and exclude. Sorry, not the three choices. We have two choices basically. Let's go with the include and exclude. First, let's go with the include here. Int include equals. Let's go with the recursion. So I'll just go with the backtrack nums comma index plus 1. So also we have to perform the this one XOR, right? So I'll just go with the, so this itself is the important part. XOR nums of index. So this is fine. Now let's move on with the choice 2 here. This one will be int exclude. This one again the recursion part here. This one backtrack of this one will be nums comma index plus 1 comma this one will be current XOR, right? So this is fine. We have to return the sum of both choices. Means here in this case we have to return include plus this one exclude, right? So we are done with the coding part. So next, only one thing is left here. We have to call the backtracking function that is starting from the index 0 and XOR equals 0. Nothing but we have to start from the index 0 itself, right, for the backtracking. So I'll just go with return backtrack. So I should have copy pasted. I've already copied backtrack. So this is fine. We have to starts with it starts with a 0, right? So we are going with the backtracking function starting from the index 0 and XOR 0. So I have mentioned 0 twice here. Num 0 0. Yeah, this is fine. So let me run this one. This is it for the code. Simple one. All right. So easy problem. This is the easy problem. Let me run the code. So the sample test cases are getting passed. So let me hit the submit button here. So all the test cases are getting passed here. Means the code works absolutely correct in this case, right? So the code works absolutely correct in this case, right? I hope the solution part is completely clear along with the this one approach and the complexities. For now, this is it. Thanks for watching, guys.